Since 1998, ISS has been in the lower orbit of Earth, and astronauts started to use this in November 2000, when the first module with long life support was added. Since then, the International Space Station has hosted over 250 astronauts from 20 nations, and over the years, the agency has assembled large space stations like NASA, CSA, ESA, JAXA, and Roscosmos. What was the purpose of the ISS? The ISS is a NASA project that was created specifically for scientific purposes. Freedom was conceived in the 1980s, following the cancellation of the Apollo crewed moon landing program, primarily due to budget constraints. By that time, humanity had taken different steps on the moon. It includes missions 11 and 12 in 1969, 14 and 15 in 1971, and 16 and 17 in 1972. As a result, space agencies focused on developing a crewed space station to conduct research, make Earth and celestial observations, serve as a transportation and servicing node for space satellites or vehicles, and serve as a staggering base for deep space exploration such as Mars exploration and the prospect of a crewed mission to Mars. After spending so much time in the vacuum, they discovered some unusual things. The tracker has discovered something mysterious about which scientists know little. The image was provided by the ISS tracker, and it shows a faint elongated white shape with a neat row of faint white dots next to it, set against the blackness of space beneath the Earth's curve. Nobody knows what this thing is, but it was captured by the space station's camera during a live feed. UFOs were suspected of analyzing massive structures, and extracellular life has always intrigued humans, scientists, and astronomers. Life may exist in the universe, but scientists have dismissed the idea. They also dismissed the possibility of aliens visiting Earth, but they hope to discover evidence of life beyond Earth due to strange sightings captured by various probes. Scientists have also discovered a powerful explosion in space. Furthermore, astronomers witnessed this massive explosion. NASA's Swift Observatory is specifically designed to detect the highly powerful known explosions in the universe, known as gamma-ray bursts, and it detected a powerful such burst. Scientists believe that these jets of energy traveling through space are caused by the explosion and collapse of massive stars known as supernova. A star should be quite massive, around 8 times the size of the Sun, to undergo supernova, but for supernova to produce the strongest type of gamma-ray burst, the star should be around 30 to 40 times the size of the Sun. This new powerful detection is so rare that we will likely only see something of this magnitude arrive from a massive star once every decade. According to Yvette Sendez, an astronomer or postdoctoral fellow at Harvard-Smithsonian Center of Astrophysics, it's a one-of-a-kind event. But don't worry, this spectacular explosion occurred in a galaxy 2 billion years away. At the distance, the energy spreading and moving through space for eons poses no threat to us. However, we can easily detect it using satellites. Furthermore, because astronauts and gamma rays are supposed to be on the same radiation spectrum as AM or FM radio, X-rays and visible light, it is very similar to getting front row seats at a fireworks show. Gamma rays, on the other hand, have the most energy. This is extremely rare, and astronomers have never seen a gamma ray burst in our galaxy due to the rarity of stellar explosions. A star in our galaxy will go supernova once every century, and a massive star, the type required to produce extremely bright or long gamma ray bursts, will only explode once every million years in a medium-sized galaxy like ours. As a result, it is extremely rare. Gamma ray bursts are also detected from afar because numerous galaxies teem with stars out in the deep cosmos. Compared to the larger universe, there are some chances for such events to occur near us. What else do you want? To detect these, you must face the direction of the blast's funnel of energy radiated into space. Because these gamma ray bursts can occur billions of light years away, the instruments are designed to detect them but are extremely sensitive. So that is one more reason why this detection is so bright and intense. How has AI been used in space? Space debris. One of the most pressing space challenges of the 21st century is how to deal with space debris. According to the European Space Agency, nearly 34,000 objects larger than 10 centimeters pose serious threats to existing space infrastructure. However, there are some novel approaches to dealing with the threat, such as designing satellites to re-enter Earth's atmosphere if deployed in low Earth orbit, causing them to disintegrate completely in a controlled manner. Another approach is to avoid any potential collisions in space. thereby avoiding debris formation. In a recent study, researchers used machine learning or ML techniques to design collision avoidance maneuvers. Another novel approach is to train ML models on Earth, transmit those models to spacecraft already in orbit or on their way, and use them for various decisions. For example, one recent proposal to ensure the safety of space flights is to use pre-trained networks on board the spacecraft. This allows for greater flexibility in satellite design while reducing the risk of in-orbit collision. Satellite data processing. Earth observation satellites produce massive amounts of data. Ground stations receive this in chunks over a long period and must be pieced together before it can be analyzed. While some crowdsourcing projects have been done to do satellite imagery analysis on a small scale, AI can come to our rescue for detailed satellite data analysis. For example, it's been used to estimate heat storage in cities and to combine meteorological data with satellite imagery to estimate wind speed. AI has also aided in estimating solar radiation using geostationary satellite data, among other applications. AI for data processing can also be applied to satellites. In a recent study, scientists recently tested various AI techniques for a remote satellite health monitoring system. This can analyze satellite data to detect problems, forecast satellite health performance, and present a visualization for informed decision-making. Planning a Mars mission is difficult, but artificial intelligence can help. Previous research has traditionally been used to inform new space missions. However, this information is frequently limited or inaccessible. This means that the flow of technical information is limited by who has access to and shares it with the other mission design engineers. But what if anyone with authority could access virtually all previous space missions with just a few mouse clicks? One day, a smarter system can answer complex queries with reliable and relevant information that may be available to aid in the early design and planning of new space missions. Researchers are developing the concept of a design engineering assistant to shorten the time required for initial mission design, which would otherwise take many human work hours. Daphne is another intelligent assistant used to design Earth observation satellite systems. Systems engineers and satellite design teams use Daphne. It simplifies their job by giving them access to relevant information such as feedback and answers to specific questions. Astronaut assistants. Do you remember TARS and CASE, the interstellar assistant robots? While these robots do not yet exist for real-world space missions, researchers are working on something similar, developing intelligent assistants to assist astronauts. While not as flashy as those seen in movies, these AI-based assistants could be extremely useful in space exploration. A recently developed virtual assistant may be able to detect any dangers in long-duration space missions, such as changes in the spacecraft atmosphere, such as increased carbon dioxide, or a sensor malfunction that could be harmful. It would then notify the crew and make inspection suggestions. Simon, an AI assistant, was flown to the International Space Station or ISS in December 2019 and will be tested for 3 years. Simon will eventually be used to reduce astronaut stress by performing tasks assigned to it. NASA is also developing Robonaut, a companion for astronauts aboard the ISS that'll work alongside them or take on tasks that are too dangerous for them. Navigation systems. On Earth, we're accustomed to tools that use GPS or other navigation systems such as Google Maps. However, there's currently no such system for other extraterrestrial bodies. We don't have any navigation satellites orbiting the Moon or Mars, but we could use the millions of images collected by observation satellites like the Lunar Reconnaissance Orbiter or LRO. In 2018, a NASA team of researchers collaborated with Intel to develop an intelligent navigation system for planet exploration using AI. They created a virtual moon map by training the model on millions of photographs from various missions. We will continue to plan ambitious missions to satisfy our inherent curiosity while improving human lives on Earth as we explore the universe. Artificial intelligence will aid us in our efforts, both in Earth and in space, to make this exploration possible. What do you think of the discovery and AI's incorporation in space? Let us know in the comments below and subscribe for more.